This is a demo of the input shaping features that are coming in ArduPlane 4.8. So they are merged in master, so if you want to try them, you can get 4.8 dev. And what input shaping is rate limits, accel limits, and jerk limits on the attitude commands. So anybody who's been flying copter will be very used to this. And now we've got them on plane 2. So first of all, we'll just have a look at the parameters. There are a couple of new parameters. So we're just going to look at the roll axis. You can see I've got an airplane here in real flight. So we've got new parameter roll to serve accel, so that's the accel limit, and then we've got a new angle gain, roll angle P. And at the moment, I have actually got the accel limit disabled, and that if you set the accel limit to 0, then that behavior is maintained from previous versions. So if you set it to 0, you can get back the old behavior if you don't like the new input shaping. And the reason I've disabled it to start with, the default is actually that it's enabled, is just to sort of show you what it looks like on this plane with the old behavior. So I'm just going to do some rolls. I'm in flight A here. We're just going to look at the roll axis. So that's sort of the roll, me going full stick left, full stick right. As you can see, it's quite an aerobatic plane. So that's the standard behavior. And then I'm going to turn on the accel limit. So this is the new default value. So this is what, if you had just updated to 4.8, this is what you would see. So you might see it's a little bit sort of slower and smoother. And then you'll see this new angle gain. So by default, we actually don't use the angle gain. It uses 1 over your existing time constant. And that's just to maintain existing behavior. And then the time constant then, if input shaping is enabled, is used for the jerk limit. So because I want to change the time constant to show you what different jerk limits look like, what I'm going to actually do is set the angle P to 1 over the time constant. So I can just do 1 over 0.2. So it would be an equivalent angle P of 5. So then that means that my angle gain then is no longer coupled to the time constant. I can change the time constant without affecting the recovery behavior. So you should see that's the same as before, because if it is 0, it uses 1 over the time constant, as it says here. So now let's go to a lower time constant. So we'll go from 0.2 down to 0.1. So you should now see that's a little bit more responsive. And then let's go from 0.1 up to 0.5, sort of show you the other way. And now you'll see that's much slower to respond. If I center the stick, it comes back very slowly to the new angle. And then back to level. So there's also a tool to help you understand this new behavior. So it's firmware.arduPilot.org/tools/webtools/kinematic-tool/plane. And actually the only way to get to this is to type in the address. There isn't a link anywhere on the WebTools page, but I'll put the link in the description of the video. So I've got this set up as we had the plane to start with. So we've got no velocity limit, no acceleration limit, and the standard 0.2 time constant. So this is the old behavior. So let's put on the accel limit of 500 as we first tried. So you'll see that the pre 4.8, I should probably explain what these graphs are. So we've got angle, angular velocity, and angular acceleration, and then way down the bottom we've got jerk. And there's 3 lines. So there's pre 4.8, that's the blue. There's the input shaping path, 4.8 plus, so that's the new input shaping behavior. And then there's the error path on 4.8. And you'll see that the error path here matches very closely to the old behavior. So previously, because we didn't have input shaping, the error path and the demand path were the same, which meant if you went from an angle demand of 0 to 30, it was the same behavior as if the aircraft was pushed off 30 degrees off its design angle by the wind, for example. So the new input shaping allows us to decouple that commanded angle versus the sort of disturbance reduction error. So the new behavior is this orange line, so you can see it is much smoother, and you'll see it's smooth right down to the acceleration level, and it's continuous in jerk, whereas previously it was discontinuous. You can see at the start here it's discontinuous even in velocity. So now it's much smoother, and you should actually notice that as you're flying around. So then let's have a look at those other time constant values we tried, and the time constant is used to calculate the jerk limit down here. And I should actually put that angle gain that we used in the example back. So now you'll see that the input shaping has become much more aggressive. So we're reaching the target angle in a shorter time, but we're still nice and continuous and smooth. And then likewise, if I go up to the higher time constant that we tried, you'll see now it's taking much longer, we're much slower to respond. But again, we're still smooth, which the pre-existing controller very much is not. So I guess the question then is, why is this better, right? What's the improvement? So there's a couple of things. One is obviously it should be much smoother to fly. You can see how smooth this is to respond. So you should notice that, for example, when you go through waypoints in auto, you should see the aircraft sort of feels much more sort of calm and collected as it makes turns and stuff. It isn't sort of going, ooh, waypoint, and immediately trying very hard. The other example, which I think this aircraft makes quite clear, is that I've got a very responsive aircraft here, but I can make it feel very slow to the pilot. So that lets you have an aircraft that can track the desired angle very closely, and it will still be very aggressive if wind or some other disturbance pushes it off its target. But to the pilot, it's very smooth and slow to respond and predictable. So the key thing that the input shaping adds is that difference between how we respond to inputs, to commands, versus how we respond to disturbances. And then along with that, it should be much smoother. And you'll have to sort of, I hope the defaults are pretty good, but you'll have to sort of have a play about, and maybe you'll use that web tool to help you understand what your gains mean. And I think particularly on big vehicles that can't respond as quickly, I think this should be a nice flight improvement. It is on by default, so if you decide you don't like it, you can disable it just by setting the acceleration limit to 0. There are also some new log items that I thought we should just have a look at. So typically you'll be using, or you will have been using, the ATT message. So we'll plot desroll and roll. And then you'll see there's this new message, ATIS. So that's attitude input shaping. And then we'll plot roll angle from that one as well. And then we'll have a look at this and a bit of the log. So the key thing is that the new input shaping log, ATIS, so that's the roll target that the actual roll is following. So you see the desired roll follows the pilot stick, and the input shaping roll follows the pilot stick, but now it's smoothed with those extra limits. And then the actual roll of the vehicle, then you should now see it very closely matches that input shaped roll angle. So that's the one of the advantages of this new methodology, is that you should now have very good tracking between your input shaped angle and the actual angle of the vehicle. So if you want to review the angle control behavior, then you want to be looking at this new input shaped roll target in the ATIS, RANG, and of course there's PANG as well. And then it's the angle error, the velocity, the input shaped velocity, and the input shaped acceleration. So yeah, that's the new log messages that you'll have to be using. So I hope everyone finds this new functionality nice, and of course, if you can test it and give us feedback, that would be appreciated. Thank you.